Okay, so let's do this first problem together on our graphing to decode worksheet number 96. We are graphing starting with these first two equations. They're linear, and we're going to graph them by using that x and y intercept. And I'm just going to write out how I found the x and y intercept on a separate sheet of paper, since I probably won't have a lot of room here. So our first equation is x plus 1 equals 3. And when we are graphing using the x and y intercepts, we're putting in 0 where x is and 0 for y. And then we're going to end up with two ordered pairs. So if I do that, and I'm going to write this out, I'm going to put in 0 where x is. I have 0 plus y equals 3. And I don't need that 0 plus. I can just leave it as y equals 3. So when x is 0, y is 3. And then I can do the same thing when y is 0. So now I have x plus 0 equals 3, and I end up with a very similar situation. So let me go ahead and graph that equation first. I'll graph it in blue, okay? So that way, number 1, I'm going to graph in blue, just to make it easier to see. So 0, 3 would end up right here. Remember, our first movement's back and forth. Since it's 0, we don't have to move back and forth. Our next movement is up and down. It's a positive 3, so I move up. 1, 2, 3. So there's our first point. Our second point's 3, 0. So our first movement's back and forth, right? It's our x movement and our y movement, up and down. So 3, 0 would end up right here. Okay? When I take this and I connect my dots, there's my first line. Now I'm going to graph my next equation, which is x, and I think this is where some people had some negative and positive issues. It's x minus y equals 1. So I'm going to put in 0 for x to start with. When I have 0 for x, I have a minus y equals 1. So really, it's a negative y equals 1. You can't have the negative on the variable. You have to know what a positive y equals. So how do we get rid of the negative y? We multiply both sides by a negative 1. A negative times a negative becomes a positive, and 1 times y is y. Anything times 1 is itself, isn't it? And then a 1 and a negative 1 times each other makes a negative 1 here. So our order pair for this one is a 0, negative 1. Now if I put in 0 for y this time, just continue it on down here, 0 for y, I end up with x minus 0 equals 1. We can get rid of subtracting 0 from anything, doesn't do anything, so it's just x equals 1. So my other ordered pair is 1, 0. So now I can graph on this line right here with these two ordered pairs, 0, 0, negative 1, 1, 0. So let's go ahead and do that. 0, negative 1 is here, and then 1, 0 is here. And if I connect my dots for that line, do you notice the point where it crosses? It crosses at an A. So the solution for number 1, okay, is at point A, and I can just write that down here in the bottom. The secret word that you write below comes from an Arabic word that means the remitting of broken parts. Oh, I'm sorry, reuniting. Sorry, I gotta put my glasses on. The reuniting of broken parts. It was first used by an Arabic mathematician around 825 AD. Okay, so A is the first letter for that.